Lesson 12.5 explores surface area of pyramids. You'll learn to find lateral areas of regular pyramids and the surface areas of regular pyramids. How are pyramids used in architecture? In 1989, a new entrance was completed in the courtyard of the Louvre Museum in Paris, France. Visitors can enter the museum through a glass pyramid that stands 71 feet tall. The pyramid is glass with a structural system of steel rods and cables. Pyramids have the following characteristics. All the faces except the base intersect at one point called the vertex. The base is always a polygon. The faces that intersect at the vertex are called lateral faces and form triangles. The edges of the lateral faces have the vertex as the endpoint are called lateral edges. The altitude is a segment from the vertex perpendicular to the base. If the base of a pyramid is a regular polygon, and the segment with endpoints that are the center of the base and the vertex is perpendicular to the base, then the pyramid is a regular pyramid. They have specific characteristics. The altitude is the segment with endpoints that are the center of the base and the vertex. All of the lateral faces are congruent isosceles triangles. The height of each lateral face is called the slant height. And they use a lowercase l for that, because I guess s isn't a very good variable, of the pyramid. The figure below is a regular hexagonal pyramid. Its lateral area, L, can be found by adding the areas of all its congruent triangular faces, as shown in its net. We can use the net to find the lateral area. So we can see we have these 1, 2, 3, 4, 5, 6 triangles. Area of a triangle is 1/2 base times height. The base of each stated formally, if a regular pyramid has lateral area of capital L square units and a slant height of lowercase l units, and its base has a perimeter of capital P units, then lateral area equals 1/2 perimeter of the base times the slant height. In a right pyramid, the altitude is a segment with endpoints that are the center of the base and the vertex. But the base is not always a regular polygon, just in our world. Our world. Classic math problem where they give us extra information. Here we go. A candle store offers a pyramidal candle that burns for 20 hours. The square base is 6 centimeters on a side, and the slant height of the candle is 22 centimeters. Find the lateral area of the candle. Well, we know that lateral area is 1/2 perimeter of the base times slant height. I'm using LA for lateral area instead of just an L, a little more descriptive. 1/2, the perimeter of the base, it's a square, so 6 times 4, and they told us the slant height is 22. So I've got 1/2 of 24 is 12 times 22. I get 264, and my units were centimeters, so square centimeters. Do we care how long it burns? Nope. Suppose you want to know the total surface area, not just the lateral surface area. Well, take the lateral surface area that we just found and add to it the area of the base. Now, when we're only going to add one base, because a pyramid only has one, unlike a prism. Find the surface area of the regular pyramid to the nearest tenth. Okay, I have a lovely formula, but I can get the perimeter of my base, I can get the area of my base, but they didn't tell me the slant height. Rats, we have to use Pythagorean theorem to find it. Not a biggie. So we're going to do 4 squared plus 6 squared equals L squared. So 16 plus 36. And square root of 52 is going to be about 7.2. Now I can plug in my formula. So I've got 1/2. The perimeter of my base is easy enough. It's a square, so 8 times 4. We found the slant height now. It was 7.2. Plus the area of my base, it's a square, so 8 times 8. So now I've got 179.2, and our units were meters. Okay, now that's what I got with rounding to the nearest tenth at that point. But if I left this value on my calculator and then plugged it in up here, it changes my value to 179.4. So be warned, a little bit of rounding will change your answers, but we've done that before. Okay, here we go. Find the surface area of the regular pyramid, round to the nearest tenth. They gave me the slant height. Yay! They gave me the altitude. They did not give me the apothem of the hexagon. Okay, so we're going to have to use Pythagorean theorem to find it. There's our little right triangle. So I have a squared plus 12 squared equals 15 squared. 144, 225. Subtract 144 from both sides, and we have a equals 9. Well, that wasn't so bad. Oh, but wait. We have to find the area of the regular hexagon. We know that a hexagon has 6 sides. 360 divided by 6 is 60, divided by 2 is 30. And now I know the side adjacent, and I want to find opposite, so I'm going to use tangent. If I multiply both sides by 9, I get 9 tangent of 30, and I type it in my calculator, I get about 5.1. I'm going to write down 96. I'm going to leave the whole value in my calculator, though. Now, if I wanted to find the perimeter, I know there are 12 of those x's around the outside of my hexagon, so 12 times that 5.196 that I saved in my calculator, I get about 62.35. I'm going to plug that in. 62.35 is my perimeter. And the apothem they generously gave us was 9. And so I can get the area of my hexagon. Now when I multiply that together with the whole value for the perimeter on my calculator, I got 280.6. They have 280.8, so they must have rounded somewhere differently than I am, but that's all right. So now I'm finally ready to plug into my whole surface area formula. I know the area of my base. I know the perimeter of my base. I am good. I didn't put a little b there. So the perimeter of the base we found was 62.35. The slant height they were nice and gave us was 15. The area of the base that we found was 280.6. And when we put it in the calculator, I get, and now I agree with the book, 748.2 square centimeters if we're rounding to the nearest tenth. The slant height, L, of a regular pyramid is the length of an altitude of a lateral face. The lateral area of a pyramid is 1/2 perimeter of the base times slant height, where L is the slant height of the pyramid and P is the perimeter of the base of the pyramid.